Picture this. You step outside on a clear night, looking up to find your favorite constellations, and you expect to see that familiar, comforting glow of our lunar neighbor. But there's nothing. Just a huge, empty void where the moon used to be. So, what if you looked up at the night sky and the moon was just gone? We're not talking about a cloudy night or a lunar eclipse here. We're talking about the complete, inexplicable vanishing of the massive rock that's orbited us for the entirety of human history. Just think about the terrifying suddenness of an event like that. No warning, absolutely zero Hollywood-style explosions scattering debris across the cosmos. It's just gone. Literally, 1 second it's controlling our tides and lighting up the darkness, and the very next, poof. How would Earth even react to losing such a massive gravitational partner in the blink of an eye? Would we even survive the night? Well, welcome to today's Explainer. We're diving into a fascinating and, honestly, pretty terrifying scenario. What if the moon disappeared forever? We're going to break down the exact chronological fallout of this global disaster, moving from the immediate shock of night one all the way to the extreme long-term climate chaos that would unfold over millions of years. It's a wild ride through scenario that shows just how fragile our world really is.
To really wrap our heads around the sheer magnitude of this loss, we have to start with a baseline. Billions of years. That's exactly how long the moon has been our constant, stabilizing companion. Since the very early days of the solar system, it's been locked in this intense gravitational dance with us. It drives our tides, it profoundly shapes global animal behavior, and it essentially acts as the planetary anchor keeping our world stable. So, losing an anchor that's been there for billions of years, that isn't just a minor astronomical blip. It's a complete rewrite of how our planet functions.
So, let's get into it. Part 1. The sudden disappearance and a pitch-black sky. In those initial, incredibly confusing hours, we'd instantly trade our familiar reality, strong, predictable tides and bright moonlit nights, for a totally stagnant world. We'd suddenly be dealing with drastically weak tides and an environment that is just pitch black. The dynamic, rhythmic pulse of our oceans and our skies would basically flatline right then and there. For us humans, the immediate experience would be one of absolute darkness. Night skies would become much darker than most people have ever experienced. I mean, moonlight would vanish completely. We are so accustomed to that ambient glow cutting through the night, even in big cities, that its sudden absence would plunge the world into an inky blackness that would feel almost suffocating. Sure, the stars might actually look brighter, but the ground right beneath your feet would be completely lost to the shadows. Moving on to Part 2, Fading Tides and Struggling Animals. This triggers a pretty brutal chain reaction. Once the moon vanishes, it takes its massive gravitational pull right along with it. And almost immediately, Earth's tides weaken drastically. Remember, the moon creates the vast majority of our tides. The sun definitely has some influence, but without the moon, that powerful ebb and flow we rely on turns into a sluggish, weak ripple. Without that oceanic heartbeat moving nutrients around and clearing out waste, marine ecosystems are severely disrupted, and the oceans basically begin to choke. And that chaos, it spreads right from the water straight to the wildlife, directly disrupting hunting, migration, and reproduction. Countless animals rely specifically on moonlight just to survive. Predators use that subtle lunar glow to stalk prey. Marine animals coordinate massive reproductive events based entirely on the phases of the moon. Birds and other species use it as a navigational tool during these grueling migrations. Without the moon, these natural rhythms are instantly shattered. Entire ecosystems would be thrown into chaos as animals suddenly find themselves blind and disoriented in a world they just don't understand anymore. That brings us to Part 3, Earth's unstable axial tilt. Okay, to really understand the scale of this catastrophe, we need to talk about axial tilt, which is simply the angle of Earth's rotation. Right now, our planet spins on a slight tilt, and it's the moon's powerful gravity that actually helps stabilize that angle. It acts like a giant counterbalance holding us steady and preventing drastic shifts over time. So if you remove the moon, you completely remove that counterbalance. Earth would suddenly be free to wobble dramatically on its axis. We'd go from spinning smoothly to tilting wildly back and forth toward the sun over the coming millennia. Which leads into Part 4, Extreme Long-Term Climate Chaos. You see, this disaster doesn't just unfold over a few days, it builds over epochs. We've talked about the immediate pitch black skies and the short-term marine disruption, but as we push into thousands of years without the moon, that wobbly axial tilt causes incredibly unpredictable seasons. The stable, reliable rhythm of spring, summer, fall, and winter completely breaks down. And as we stretch into millions of years, that erratic tilt results in extreme hot and cold climates all over the globe, radically reshaping where life can even exist. The extremes we'd see would be staggering. We're talking wildly unpredictable seasons, far hotter peaks, and much, much colder freezes. Because the Earth's tilt would change so drastically over time, parts of the world that are currently tropical could be plunged into permanent, deep freezes. Meanwhile, regions like Antarctica could suddenly find themselves tilted directly at the sun, baking under unimaginable heat. Our stable climate is literally a luxury provided by the moon. Without it, our environment turns into a chaotic, violent pendulum just swinging between boiling and freezing. So, the ultimate question. Part 5. Will humanity actually survive? The surprising answer, based on the data, is that humanity would actually probably survive the immediate disappearance. The initial shock of a missing moon wouldn't wipe us out overnight the way, say, a giant asteroid impact would. We've got technology, artificial light, and we're highly adaptable. However, future generations would be living on a very, very different Earth. Our descendants would inherit a highly unstable, unpredictable planet. They'd be forced to constantly adapt to wildly shifting coastlines, dying ecosystems, and chaotic climate extremes. So yeah, survival would be possible, but it would be a constant, grueling struggle. It kind of brings a deeply philosophical perspective to all this science, doesn't it? Sometimes we just don't realize how important something is until it's gone. The moon seems so wonderfully ordinary to us, mostly because we see it every single night. We totally take it for granted. But the reality is, without it, our planet would be far, far less stable. It is essentially our silent guardian, keeping the oceans alive and the climate steady just by being there. So, I'll leave you with this final thought to ponder tonight when you look up at the sky. Would you want to see a moonless Earth, knowing all the chaos, the darkness, and the wild instability it would bring? It certainly makes you appreciate that glowing rock a whole lot more. If you enjoyed diving into this scenario, let us know your thoughts in the comments below. And don't forget to subscribe to Curious Orbit for more deep dives into incredible science mysteries. Thanks for exploring this explainer with us, and keep looking up.